Hi, welcome to Turkish Engineering. In this video, we are going to solve two problems for velocity in a plane. So let's start by the first example or first problem. So I have a velocity vector, has a magnitude of 25 meters per second. So I will put my velocity vector. It's actually, if you are just seeing that you have a vector, velocity vector, and it is not talking about y component or x component, so that means it's actually giving you the resultant of your velocity. So your velocity will be just intersecting and actually will be onto your path. So this is my path. I must have a velocity like this, okay? It's 25 meters per second. This is my velocity. What about the y component? If its y component is minus 13 meters per second, what are the possible values of its x component? So actually here I draw my velocity in a wrong way. Why? Because as you see here, my y component is negative. That means for the y-axis, that must be downward, right? If your y velocity is down minus, that means it's downward. It's not upward. So my drawing was upward, so I see that I made a mistake. So how can I just make this correct? I will just take the same idea but put it in the reversed way, okay? So actually if I have this magnitude of velocity, and I know that my y component, let's put first my y component, okay? Let's start by the y component because this is unknown in direction. It is known in direction, but the other one I don't know its direction. So I will start by putting my y velocity. It is my y velocity, Vy. This is Vy, which is equal to 13 meters per second in the magnitude, and its direction is given by putting downward. So you don't need to put here minus, because it is I'm not putting arrow here. It is not a vector. It is just a scalar quantity here, because I'm putting just magnitude, okay? So, but here you will show that it's downward, so that will give you the minus sign, okay? The drawing will give you the minus sign because it is downward. What about the velocity if the magnitude of it is 25? Actually, here I have two possibilities only. Why? I will put my x-axis. This is my x-axis, okay? This is my x-axis. And I will put my y-axis like this. This is my y-axis. If I am going in y-axis downward, okay, my y velocity is downward, okay, I will put the y. My y velocity is downward. So I cannot be in the first quarter. This is the first quarter, this is the second quarter, this is the third quarter, and this is the fourth quarter, okay? So I cannot be in first or second quarter. I must be in third or fourth quarter. So I can put my resultant velocity vector by this way, okay, or by this way. I have just two possibilities. If the question is giving, it's not minus, it is giving just magnitude and not its direction, so our possibilities will be 4. I can be on first quarter, second quarter, third or fourth quarter, but it's giving the magnitude, it's minus direction actually. Magnitude is 13, but it's giving the direction, it's downward. So I can only be in third or fourth quarter. So this is the velocity vector, this one, okay? The resultant one. So what can you say about Vx? It can be minus this one, okay? The first possibility, it can be this one, Vx, or it can be this one. But the magnitudes will be equal to each other. The magnitudes will be equal to each other because we are talking about the same triangles. But it can be positive direction or negative direction. So possible values of its x component will be plus something and minus something, and they are same in the magnitude. So how can we calculate? Actually, I will put our formula. V squared will be equal to Vx squared plus Vy squared. I know I'm asking for Vx, right? So I will just put it in the just left side, or yes, I can put it in the left side. And so I will move this one to the other side. So Vx squared will be equal to V squared minus Vy squared. So what about Vx? So I will take square root of both sides. So Vx will be equal to square root of V squared minus Vy squared. Okay. So I know the Vx will be equal to square root of 25, which is V, minus 13 squared. Okay. Why here I put minus, and actually Vy equal to minus 13, and why I'm not taking here minus 13 again? Actually, I will take here the magnitudes, only the magnitudes. So Vy, its magnitude is 13, so I will put 13. But the minus is coming from this. Because I sent Vy to the other side, it has minus sign. But Vy, I will put just 13. Even you put into parentheses, you will put minus. When you take square of it, that will give you positive value. So don't worry. Just when you are taking square root, put minus or negative, that will give you the same answer. But this one is very important, because if you are calculating Vx, you must put here minus. The resultant minus Vy. But if you are calculating V, actually the V, so you will have Vx squared plus Vy squared. It's not minus here. But here minus, because I sent Vy to other side, so I must have minus sign. So let's just take the calculator. So I will take square of 25 minus square of 13 into a square root. So I will get 21. What's my answer? 21.35 meter per second. This is my Vx. Okay, this is my Vx. What about the directions? So I said this is the magnitude, right? So Vx can be just two possibilities. It can be by this way, okay, or the other possibility, it can be in the opposite direction. So these are the only possibilities, okay. And the value, actually the magnitude will be just one. I have only one possibility. It cannot be bigger or smaller than this one, but it can be positive way or minus direction. But the magnitude will be same for both cases, okay. Yes, this is the second problem. We have a pool ball, okay, just draw the pool ball, okay. It will move with two components of velocities. So let's draw the velocities. I have a velocity in x direction, which is 0.5 meter per second, and I have Vy, okay, which will be 0.8 meter per second. So I must get a resultant of them, right? So when you put here Vx, then you will put Vy. So you must get a V, resultant V. So let's calculate this one. This is V, and this is Vy, and this is Vx. And I have here angle theta. So just start with the theta. It is just arctangent of Vy divided by Vx. So I know the Vy and Vx, so I can put theta will be equal to arctangent of 0.8 divided by 0.5. So that will give me the angle, arctangent of 0.8 divided by 0.5. That will be equal to, actually it is nearly equal to 58 degree. What about the magnitude of V? As you know, it's just will be square root of Vx squared plus Vy squared. Vx squared plus Vy squared. So I will put V will be equal to 0.8 squared plus 0.5 squared. Okay. So this will be equal to, let's make it square root of 0.8 squared plus 0.5 squared. So that will give me the answer 0.94 meter per second. This is my magnitude. I know direction now, and I know the magnitude of the velocity. So I will put my velocity here. That will be my velocity, okay. This is the velocity, and I know the angle here, angle theta, which is equal to 58 degrees. So my path, actually my path will be just like this. When I reach the final point here, and this is the initial point, so this one will be delta r. And what about this point? So this is my displacement in x. So this distance will be just delta x, and this displacement will be delta y. So I have a second triangle here, which is my hypotenuse here, delta r, and horizontal, my base is delta x, and my height is delta y. So actually you can calculate delta r by two ways. So delta r will be equal to just velocity times time, or you can calculate it by this way, delta x squared plus delta y squared. So we will see that they are equal to each other. Let's start by the first part. Delta r will be equal to our velocity, okay, times time. So this one multiplied by time. What about the time? Actually, it will travels for 0.4 seconds. So let's put 0.4 seconds. You will see that the seconds will cancel each other. So 0.94 multiplied by 0.4, you will get 0.37. Just put this one, other one. So this is my displacement, the total displacement. What about the second one? I must calculate first delta x, and which is vx times time. And I know my vx, my velocity in x, actually this is 0.5 meter per second, and my time is 0.4. So that will give me 0.2 meters. What about the y? Y displacement will be just velocity in y times time. Because as I said, the velocity, actually the velocity x will be equal to delta x divided by delta t, or just say t. So you will see that if you need delta x, you will multiply both sides by delta t. So that will be vx time, okay, vx multiplied by time. So if delta y, that will be delta vy multiplied by time. The formulas which I'm using here is coming from this knowledge, okay. So let's continue here. So I will put my velocity in y-axis. So it's actually 0.8 meter per second, and my velocity, actually the time. So I will get 0.32 meters, okay. So when you put delta r, which will be equal to square root of delta x squared plus delta y squared, you will get square root of 0.2 squared plus 0.32 squared. You must get the same answer. We will check now. Square root of 0.2 squared plus 0.32 squared will give you just the same idea, 0.378 Actually here 7, but sometimes we made some roundations, so actually they are nearly equal to each other, okay. They must equal to each other, not nearly, they are equal to each other, but we made some actually roundations here. Actually this is not 0.94, actually some we have some numbers after this point. So when you take the exact value, you will see that delta r in this formula and the other formula will be equal to each other, okay. So actually when you don't have any acceleration, you have just constant velocity. That means you are moving in a uniform motion. Uniform motion means your velocity is constant, there is no acceleration. This is our case here in part chapter 3 part 1, velocity in a plane with without any acceleration. So that will be easy, but challenging one will start in the next video. So we will study acceleration in a plane and displacement in plane, which will be just depending on our velocity, initial velocity and acceleration. So we will solve some problems and we will make an introduction for acceleration in a plane. See you in the next video.